Hello folks, Dad Set here. Today I'm going to be revisiting expressions. It's been some time since I've done a video on expressions, and I urge you to review my previous videos on the subject. The links to those videos are down in the description box. I will not be reviewing expressions as much as I will be building on what I've already released. I will be talking about conditional expressions and the effect of time on expressions. The conditional expression is perhaps one of the most useful tools in my arsenal, given that it takes the strict conditions that are set and returns an outcome in the form of if and else. We usually find if-else statements in programming. However, I usually avoid writing scripts for character specifics because expressions are much quicker and more flexible, and I can create them on the fly in program as part of my workflow. Let's take a look at a problem. This is a fully grid character that I created. The problem is that when I bend the character over, her glutes do not deform well. I could bend the hips to correct the issue, but I don't think it's a good idea to use such a central element of the rig to correct for deformation, especially since the hip bone has so many dependents. The answer to this problem is, of course, expressions. I solve part of the problem already by raising and lowering the glutes when the character bends forward and backwards, but that's not enough. Now I need to rotate them as well. Okay, so what I have here is a much simplified portion of that rig. The components are, of course, the ilium, the hip, and the three bones here that represent the glutes. Now what I want to do is to I want to have these bones correct automatically when the femur rotates. So first of all, I want to check my limits. So I'm going to go maybe 25 degrees one way, and then maybe 85 degrees the next way. Now the thing is, there's an easy way to do this without using expressions, and I'm going to go ahead and show that. And that's going to be in the motion options. So basically what I would do is I would take this bone, and I'm only going to be using the pitch, so I'm going to use same as item, and I'm going to rotate it off the femur, and it's done. Now this may look like a good solution, but as you move closer to 85, it rotates too much because this is a one-to-one solution, and that's not what I'm looking for. I'm looking for an asymmetrical solution. I need it to move less on the top and just a little more on the bottom, on the down pitch. Just a little bit on top and slightly more on the down pitch. So while I can do things such as alter its starting point or alter the degrees in which it would move, such, let's say I make it 0.5, and now it's moving a little less, but it's still a one-to-one ratio and lacks asymmetry. Furthermore, you cannot manipulate time with this method. So by using this is sort of a beginner's method of doing this, but by doing this, what the artist does is he backs himself into a corner. He removes his flexibility when it comes to trying to get this glute to move relatively with the femur. So we are going to cancel that and go into expressions. Now, since we're dealing with the ratio, I'm going to use the mapRange function. And the reason being is because I am dealing with ratios. And if you want to see how it's done, or a more in-depth lesson on how to use that function, look at my earlier videos. It's in the description box. mapRange femur.rotation time dot pitch, and I'm going to set my limits 0, 20, 0, 15. And so let's go ahead and apply that expression in the graph editor. So let's go here. Let's find this. Let's copy this one. And let's create a new expression. We're going to call this one glute auto pitch up. And let's paste it here. And it's validated. So now I need to find the channel. I'm not sure which one that is because it's in green. Glute middle. Yep, this is the one I want. And apply it. And we know that it works because we saw it change in the graph here. So let's move this out of the way and see how it works. Okay. We got good motion at the top, but the bottom needs to move less. So what I'm going to do is I'm going to add a second expression. And it's going to be mapRange again, femur dot rotation time dot pitch, 0, negative 85, 0, negative 20. I'm going to grab those. Now, generally, I would just simply type these into the graph editor, but I want the audience to see what I'm typing. So that's the reason why I'm doing it this way. I'm going to keep it on the same channel. I'm going to create a new expression. I'm going to call it glute auto pitch down. And I'm going to paste that new expression and I'm going to apply it. And there it is. So both of these expressions are running now. But there's a problem. And the problem is we don't know what the return value is here. Both of these expressions are running. And what Lightwave usually does is it returns the highest value. The problem is that things get wonky when it comes to overlapping expressions. And so it's not a good idea to overlap them. So what I'm going to do is I'm going to set limits on them. And to do that, I'm going to take the expressions as they are, and I'm going to set a minimum and maximum on it. So this will be max 0. It's going to be comma, and we're going to add another parentheses. And what this does is it will it will act on every value. I think this is going to be above 0, but it will not allow it to go below 0. And I'm going to show you an example of this. So we're going to get rid of that. We're going to go with the pitch up. And we're going to grab that expression again, this whole thing, copy it, paste it here, and see what happened. It disappeared. It will not go below the value of 0. And so if I run the expression now, it'll stop. The pitch will stop at 0. Now we want to do just the opposite for the second expression. That one we're going to go minimum and 0, comma, go to the end, add another parentheses, copy this expression, go to the, let's turn this on, go to the second expression and paste. And now you see just the opposite. Only the values below 0 will return. But this puts us in a dilemma, because as we can see, both of these expressions are running, but they're canceling each other out. It will only run one expression because the minimum and max values will cancel each other out. And this is where the conditional expression comes in, because I want to use both expressions, but how do I do that if they're canceling each other out? Basically, what I want to do is I want to set a condition. This operates basically like an if-else statement in scripting and programming. So first I'm going to call my time.pitch, and this time I'm going to put it in, we'll just go less than 0, then put a question mark there. I'm going to run, if it's less than 0, I'm going to run this one. If it's so, I'm going to go here. If it's greater than 0, that's the colon, I'm going to run else, basically, run this expression. Let me put a space there. So basically what this is saying is, with the question mark behind this expression, all of this statement here means if. And basically it's saying if femur rotation is less than 0, then run this expression, everything before the colon, which will stop here. Else, which is what the colon means, run the second expression. So I'm going to copy all of this into the expression channel. So I'm going to go new, and we're going to write conditional. And we're going to paste that, and it went. So I'm going to turn off both of these, and I'm going to apply this expression, and there they both are. So let's see how it goes. And there we have it. That's the conditional expression. It's also called the compound expression. Now we're going to take a look at time, because time is something that I did not talk about in the other three functions. I pointed to it, hinted around it, but I didn't really talk about it. What if I wanted the second motion or the down motion to start sooner or start later, or either of those motions? Well, this is what I meant with, while using the motion editor or the motion options, you limit your flexibility. This area here, if you remember when I used the sine function, you have to remember any variable that's used in Lightwave is assumed to have a 1 beside it or to be multiplied by 1. Time is literally like this. It's multiplied by 1. There's an operator there. It's just that you don't see it. All of these have operators beside them. And I can apply a variable to time to manipulate time. In fact, let me show you in the graph editor. There's time. Just multiply it by 1 and you will not get an error. It will be the same thing. Now, if I took time, let's say that second time, and I multiplied it, let's say by 0.95, it will go slower. You see it move. Well, actually, that will be faster. If I go 0.85, you see it move again. What this means is it will execute that expression later. And you can see it happen. It's no longer immediate. If I set it to 1 again, everything happens immediately. And if I want to set it for, if I set it at greater than 1, let's say 1.05, no, let's say 1.5. You see, it shifted. It executes early. It goes through the entire cycle early. Now, this is very useful. It's useful for doing shocks. It's useful for doing muscles. It's useful for a lot of things. In fact, you've seen me use this technique to animate my characters. I use one expression and I just simply apply some type of bias to time using a null object, or I would just input the values directly like this. But this is why time is useful, because it allows you to get a great deal of control and flexibility without the need to keyframe every single motion. And I'm going to show you some examples of that. Now, when you're using time in Lightwave, think about it in terms of the x-axis in algebra. If you take x, y, and z, which are the three coordinates in 3D space, you know that y is a function of x and z is a function of x and y. But time is sort of out there. So think about it like this. When you're using time, all of this area, well, let me go ahead and simplify this. Let's get rid of the mapRange. Okay, this is the basic format for an expression. So when you're thinking about femur.rotation.pitch, all of this represents a coordinate. So you can clump all of those into something like y. This time represents something more linear. This is x, although you can do whatever you want to do with it. I find it easy to think about it that way, and the example is such as I remember when I was doing algebra. If we can go to the graph editor for this. If you remember the shifting function in algebra when you're graphing, let's say you have a graphing calculator, or this will do. Let's take a function, something simple like a parabola, for instance. So a parabola would be a squared function. So we'll go x, there it is. And what's my caret? Squared. There we have our parabola. And in order to shift the parabola, if you wanted to shift it, let's say right, then you would go x. Let's say we want to shift it. Let's say we want to shift it shift it right 5. You go x plus 5, close parentheses. And if I want to move it up and down, of course, you square the x, get rid of this and that. X plus 5 goes up, x minus 5 goes down. We're only concerned with left and right because that's what I'm dealing with. We're only dealing with time here, but this is a good example of how shifting works. And this is very basic junior high school algebra. So let's go ahead and square this again. Let's go ahead and move the parabola back. And so when you're using time in Lightwave, think of it like this. Basically, only thing that you're doing is that you're shifting the function left and right. And it doesn't matter what you're using, whether it be sine, whether it be some type of conditional, it doesn't matter. Once you go in and you start messing with time, all that you're doing is you're shifting the value or the function left, right, or whatever the case may be. So let me give you an example of some of this at work. Now what I have here is a motorcycle, and what I want to do is I want to make this motorcycle drive over this bump just to see how it would look with the basic animation. And so I keyframed the ride over the bump. And there you have it. I've already applied an expression to the wheels. So those are not keyframed at all. Those are basically running on the node here. But this is very plain. This is not polished at all. And in order to polish it, what I've seen even today lots of guys doing is keyframing the forks and then going through all of that rigmarole in order to try to get it to work. Again, this is where, number one, the expressions come in, and this is where time comes in. But there's also another component at play here: when to start or where to start those cycles in the sine expression. And I'm going to show you. Just a moment. We are going to set a preview. Well, first of all, we've seen it with the expressions off. So let's see it with the expressions on. So I've just turned on the expressions. And now take a look at it. There was no keyframing of the forks whatsoever. This is all expressions. So from that plane animation, now the motorcycle has a sense of weight. That sine expression is doing its thing. The time delay, where the forks actually compress and lift the bike up, is also at play here. And all of this is done without applying a single keyframe to the forks. This is the power of expressions.